Let us start with the last problem, that is a simply supported beam with overhanging at one side, and there is 20 kN loads and there is 15 kN loads. So we have already calculated the reaction RA and reaction RB. Now let us try to find out some value of axial force. Suppose we have a particular section at this point, okay, so and this distance is 2 meter. At 2 meter distance from point A, we have a section, and this section we have to calculate the shear force. So this is the simply supported beam. So this is 20 kilonewton force at 1 meter distance, and this is 3 meter, and this is 15 kilonewton load. This is 2 meter distance and it is 1.5 meter. So the section is at this point. So this distance is 2 meter from the point A. So first of all, what we have to do? We have to draw the influence line diagram for shear force. Okay, for we have created the influence line diagram for simply supported beam only, and now we have to draw the overhanging part. So what we have to do? We have to increase this, we have to extend this line up to the end point of the beam. Okay, so this is the influence line diagram for shear force. Now you draw one vertical line below the 20 kilonewton load and one vertical line below the 15 kilonewton load. So suppose this is Y5 and this is Y6. Now this distance is 1 meter, and this value is 1, and this value is 1. So we can write, if I consider this triangle, so 1 by 4 equals, now we have to consider this triangle, that is Y5 by 1, Y5 by 1, so Y5 equals 1 by 4. So now we have to calculate y6. So just consider this triangle. and this triangle. So we can write 1 by 4 equals y6 by 2. So this distance is 2, and from this point to this point A to B is 4 meter. So y6 equals 2 by 4, that is half. Now shear force will be, so this section is xx, so shear force at xx section, so 20 into y5, that is 1 by 4, plus 15 multiplied by half. So this is 5 plus 7.5. So the answer is 12.5. And this negative zone, this indicates the shear force value will be negative shear force. Okay. So actually the shear force will be the negative shear force. So what will be the shear force diagram here? The shear force diagram will be like that. Okay, so you can see at this section we have the negative shear force. So this 12.5 kilonewton will be the shear force value, and this is negative shear force. Let us try to do another problem. So suppose this is a simply supported beam, say 8 meter length, and we have UDL at this position. Okay, so this is 2 meter and this is say 2 meter. So now we have to calculate the reaction. So draw the inference line diagram for the reaction RA. So this is 1, this is ILD for RA. And the value of the UDL is suppose 10 kilonewton per meter. Now for the UDL, the rule is like that: you draw a vertical line at this position and at the starting point of the UDL and the ending point of the UDL. Okay. Now we have to calculate this area. We have to calculate this area and we have to multiply with this 10 kilonewton, the value of the UDL, that is intensity of the UDL. So suppose this is x1 and this is x2. So total distance is 8 meter and this distance is 2 meter and this distance is 6 meter. So we can say 1 by 8 equals x1 by 2, or x1 equals 2 by 8, that is 1 by 4. And for the second case, that is 1 by 8 equals, so x2 by 6. So x2 equals 6 by 8, that is 3 by 4. Now a reaction RA will be 10 multiplied by area, okay, or load multiplied by area of the UDL. So this area, let us calculate the area. So this distance is 4 meter. So x1 plus x2 by 2 multiplied by 4. So this is the area. So x1 is 1 by 4 plus x2 is 3 by 4 by 2 into 4. So that is half into 4. So this is 2. So the reaction RA will be 10 multiplied by 2, that is 20 kilonewton. Now find out the reaction RB. So we have to find out this area. This value is 1, and this is actually symmetrical problem. That's why the reaction RB will be the same like as RA. Okay. So x1 and x2 will be the same. x1 will be 1 by 4. So this distance will be 1 by 4, and this distance will be 3 by 4. So the total area will be 2. So now RB will be 10 multiplied by 2, that is 20 kilonewton. Now let us do another problem. Say this is 1 meter, and 4 meter. So total 8 meter span, and this value is 20 kilonewton per meter. So now calculate the reaction. This is 1, and we have to find out the area of this particular portion. So if this is x1 and this is x2, so this distance is 4 meter, and this is total distance is 8 meter. Now we can write 1 by 8 equals x1 by 4. So x1 equals half, and 1 by 8 equals x2 by 7, or x2 equals 7 by 8. So now calculate the area. Area will be half plus 7 by 8 divided by 2 multiplied by 3. So the value is 2.0625. Now the reaction RA will be 20 multiplied by 2.0625. So that is 41.25 kilonewton. Now calculate RB. So the influence lines diagram for RB, and calculate x3 and x4. So this is 1, this is 4, and this distance is 8, this is 1. So 1 by 8 equals, we can write 1 by 8 equals x3 by 1. So x3 equals 1 by 8, and for x4 1 by 8 equals x4 by 4, hence x4 equals half. So can calculate the area. 1 by 8 plus 1 by 2 divided by 2. So that is 0.3125 multiplied by 3. That is 0.9375. Now the reaction RB will be multiplied by 0.9375. That is 18.75 kilonewton. So the reaction RB will be 18.75, and the reaction RA will be 41.25 kilonewton. Okay.